I would like to, of course, we are immensely grateful to the British School and its director, Rebecca Sweetman, and of course to Yorgos, that today is helping us very much, for generously hosting the event. Lastly, I would like to thank all the personnel of Athena RC back home in Xanthi and here in Athens, that everyone involved in the project for helping us and for supporting the event. Your presence and involvement are truly appreciated. Despina has already mentioned and analyzed the goals and the background of the lab, so I will not extend any further. The only thing I have to say is that the laboratory has conducted projects ranging from Intra Site analysis to macro scale analysis and hopes for the future to integrate GIS data with Unity 3D. Today's presentation will not only describe the execution of these research projects, but will also address theoretical issues of GIS applications with a mindset of archaeologists studying landscapes or sites through digital processes. And if there is a field where GIS can be extremely useful, of course, this is the archaeological excavations, where the organization and management of the complex spatial data generated during the field work and the need for analyzing and interpreting this data is always a pressuring issue. Yes, this is me 30 years ago, 28 years ago. From very early on in the history of the employment of GIS, field archaeologists, especially in the UK, in the United States, and of course in the Netherlands, understood the great potentials of GIS tools for data handling, the organization of findings, the identification of possible correlations in the spatial distribution of objects, but also for the detailed study of each individual object. And this is exactly the way we have employed GIS tools in the archaeological excavation of Karabournaki, a large site in the Thermaikos Gulf, which a number of scholars identify as the harbor of ancient Thermi. At Karabournaki, the GIS was used mainly as an organizational, as a data handling tool that allowed for better management of the material, especially of the numerous ceramic finds. However, as the familiarity with the use became greater, it soon became clear that the spatial capabilities of the program, and especially the possibility to move from the micro scale of the excavation to the macro scale of the wider environment, allowed us to express a wider set of questions than what the restricted space of the excavation allowed. Since 2002, we have been working. The lab might have a history of 2 years, but we're working on this technology 20 years now. Since 2002, we have been working on a geospatial platform, a database that was implemented using various GIS softwares. The GIS platform we ended up using was based on custom versions of QGIS, but you may all know it, an open source GIS software that provides a wide range of tools for spatial data management, analysis, and visualization. From the initial design stage, our main objective was to create a digital dataset that includes various levels of SHP files and metadata. Our goal was to develop a system that allows fast and efficient data reporting, integrating both vector and raster data sources and facilitating work with data at multiple scales in order to accelerate mapping and reporting during the excavation period. The methodology for designing the GIS project involved making some significant decisions about the nature of the archaeological data being collected and how they will be organized and represented in the GIS. These ontological, decisions included determining which data would be included and at what scale they would be represented, selecting an appropriate coordinate reference system, establishing data standards, and selecting the appropriate software and hardware. It became clear to us through trial and error, mostly mine, that making the right ontological decisions during the design stage was critical to the success of the project. This is the stage where the logical and physical structure of the project platform must be precisely designed to account for the constraints imposed by the electronic, translation. The most obvious result for us was that all permanent architectural remains were geographically mapped and correlated with other findings within the GIS environment. permitting us to identify patterns and relationships that were not apparent from the non-spatial data. This created a digital map of the excavation site, which allowed us to understand the relationship between architectural features and other aspects of the site and identify patterns of use and activity, especially within open and closed spaces. This also set the basis to create 3D models of the architectural features, which can be used now to further analyze and visualize the spatial relationships between different features. The use of layers enabled the organization of complex data, facilitating multiple visual options at different scales and levels of details. By thematically organizing the excavation based on the period or type of feature, specific findings could be presented individually, making them easily identifiable from the complex and visually overlapping objects. At the same time, the execution of complex spatial queries sought correlations and connections between specific categories of materials that can be considered as potential indicators of the presence of functional areas. By combining this spatial and non-spatial data and performing complex queries using GIS, for instance, in our case, identifying clusters of artifacts or features in close proximity to each other, we managed to gain a more complete understanding of the excavation site and the behavior and activities of the people who occupy it. The example of Karabournaki has demonstrated the usefulness of GIS as a tool for archaeologists to shift from analyzing individual sites to conducting analysis on a larger scale. By allowing researchers to map and analyze data on a larger scale, GIS can help identify patterns and relationships that may be challenging to discern using conventional methods. And you see in this small video how, in the case of Karabournaki, we can move from the level of the architecture of the single stone to the broader region of North Aegean in a single project, which is very important for us. You can see here all the late archaic and early classical cities in North Greece. Following this approach, AeGIS Athena investigated how the environment has influenced settlement patterns and ultimately the landscape in the extensive geographical area of Aegean Thrace. Ancient texts describe this Thracian land as fertile and abundant in crops, with references to the land as a granary that attracted Greek settlers from Asia Minor. However, in order to understand the past economy accurately, we must expand our comprehension beyond textual sources and evaluate the extent to which the descriptions match reality and the understanding of the ancient groups in the area. Therefore, we aimed to investigate the productivity of the area through the lens of historical ecology, which can assist us in evaluating settlement strategies and land management practices in response to the unique ecological features, such as the extensive wetlands, the periaquatic soils, the fluvial topography, and the minerals that influence the landscape of the region. A key aspect of our research was the development of a GIS platform that facilitated the integration of a broad range of data from various sources, such as other databases and field tests and formats, into a coherent and consistent structure. This platform was designed to analyze and visualize environmental data and field test results implemented in the area. In this context, we generated various maps and conducted spatial operations to assess soil productivity and site distribution using customized queries. Additionally, multi-criteria query forms enabled us to scrutinize and visualize various data and verify existing interpretations derived from the integrated evidence. By inserting our data into this synthesis, we were able to evaluate and utilize a more extensive range of environmental attributes, as well as enhance our understanding of particular terrains. In this approach, we combined historical literature with diverse information derived from systematic research conducted in the region over the past century, including archaeological, geological, meteorological, and palynological data. Our objective was to construct an environmental history of the area that accounted for the utilization and exploitation of natural resources, the transformation of various landscapes, and particularly to explore the interconnectedness that characterized human activity in the region. The study showed that the environment, specifically the alluvial deposits and the fluvial landscapes, had a significant impact on settlement patterns in the area's economy. Contrary to the traditional belief that the region's wheat belt soil made it primarily agricultural, evidence from this project of poor fertility and low productivity challenged this view. Instead, environmental variability and soil workability emerged as important factors in determining the settlement and economic strategies of the local Thracians or Greek colonists. And you see here pictures from the river in Xanthi, Kossuthos. Alternative theories about the establishment of apikeia, of the colonies, including regional and interregional transit trade, were suggested instead of agriculture, while within this environmental local communities appear to have employed unique land management practices, such as mixed farming, self-sustained animals like the short-horned cow that still lives in the mountains of Xanthi, and seasonal habitational patterns. Let's shift now our focus to network analysis, which has emerged as a powerful tool to study ancient trade routes. Scholars can now use this technique to analyze factors like distance, transportation costs, and other variables that Professor Saris also mentioned, to visualize and understand the flow of goods between various locations. A good example of this is the study of the sanctuary at Kalapodi in central Greece, the famous oracle of Apollo at Abe, where this year, 50 years of excavation of the German Institute, where in the context of my friends, who is down there, Dimitris Grigoropoulos project, we have used GIS techniques to create a network dataset that included all the land and maritime routes and ports involved in the distribution of goods during the Roman period. The process of reconstructing ancient land routes involved analyzing historical and archaeological data and integrating data from a variety of sources, including archaeological surveys, historical maps and text, and topographical data. After reconstructing the land network, various transportation scenarios based on what we call service area analysis were examined to optimize transportation networks and estimate travel times and distances for different modes of transportation. And you see here, for instance, an isotropic surface movement from the port of Andikera, a port who lies on the south side of the area. On the other hand, reconstructing sailing routes proved to be the most demanding aspect of examining maritime trade routes and ports. To accomplish this, we developed a network vector-based dataset that incorporated all ports and navigable waterways, drawing on multiple sources, including nautical charts, historical maps, and modern navigational data. To determine the most efficient path between 2 points, including the cost of traveling over water, such as distance, currents, and other relevant factors, shortest path analysis was conducted using network analysis tools in QGIS. Through network analysis, we were able to propose alternative trade routes by taking into account navigational features, wind patterns, and other factors that may have impacted ancient trade routes. By integrating this information into our analysis, we can now suggest trade routes that may not have been immediately apparent using traditional methods. For instance, you see here, after a lot of discussion with Dimitris and a lot of experiments, for instance, trade routes that lead to Chalkis directly from Alexandria. In summary, the use of network analysis through GIS software has allowed us to visualize and study ancient trade routes leading to Kalapodi, particularly maritime trade routes. By reconstructing land and sea networks and exploring various transportation scenarios, we can now gain insight into the flow of goods and identify alternative trade routes. Although necessary to archaeological research, geographic information systems have their own structural limitations. Commonly used spatial representations usually provide quite monolithic aspects of the complexity of landscapes. Cartographic representations and point-based maps are extremely useful, of course, for modeling quantitative data, for instance, the dispersion of pottery from Karabournaki that you see here, but they are rather insufficient when it comes to understanding the qualitative aspects of human experience and praxis, that is, movement, visibility, perception of the landscape, etc. Real-time development platforms, such as game engines, present a promising solution to create coherent spatial models by combining them with GIS data. By incorporating gamification elements, it becomes possible to explore dynamic elements in a 3D environment, which can be challenging to grasp when working with two-dimensional maps. This is because gamification techniques encourage involvement, engagement, and problem-solving skills. In this regard, we employed Unity 3D to reconstruct and analyze a set of archaeological landscapes that we had previously investigated in different GIS projects over the years. Due to its game-like features, Unity 3D offers an accessible, engaging, and cost-effective method for representing archaeological data, allowing users to comprehend complex concepts through performing their own simulations. While simple, these models provide a means for testing the validity of archaeological assumptions regarding the past behavioral strategies of people. Additionally, using Unity 3D simulations enable researchers to explore the landscape as an open environment rather than a static representation, facilitating the examination of complex, multiscalar, and multivariate archaeological scenarios beyond existing conceptual hypotheses. Multi-view 3D reconstructions are not necessary, and even low polygon models of environmental and cultural features, like the houses we see here for Karabournaki, can demonstrate what John Epstein refers to as emergence. The reconstruction method in Unity 3D involves importing GIS data into the software and using it to create a detailed and accurate virtual environment. For each model, the best source of information for generating virtual terrains, such as elevation data, height maps, architectural drawings, 3D models, and results of viewshed analysis, is sought from data produced in previous years in relation to various archaeological projects we conducted in AeGIS Athena. Thanks to the use of Unity, we were able to explore real-time movement, landscape perception, built environment density, proximity, and physical volume perception of the buildings across various sites, ranging from large-scale areas, such as the paleodelta of Nestos that you see here, to small-scale microscapes, like the stretch of Via Egnatia passing through the villages of Xanthi, and of course to larger settlements like Karabournaki in a rainy day with blue sky. I don't know how managed to do that, but I did it. Our focus on visibility as a means of detecting settlement relationship and strategies for accessing and overseeing critical resources and space. To address the issue of individual perspectives, which is often absent from geospatial platforms, we employed computational modeling based on GIS data. This approach has significant potential for testing relationships between individual actions or usage. By leveraging Unity 3D, we can create visualizations of archaeological data, including settlement patterns and micro-landscape reconstructions. Such visualizations can help users comprehend intricate data sets and patterns in the archaeological landscape. Despite the widespread use of GIS in archaeological practice, the archaeological community has not yet fully come into terms with the idea of this technology as an integral part of archaeological education. To a lot of archaeologists, the GIS tools have an auxiliary role and can aid the organization of data, but at the same time, they are limited to that role and cannot further enhance more complicated concepts of archaeological research and analysis. As a result, digital archaeology continues to be a specialized field of expertise, often by people unrelated to academic and field archaeology. And the development and dissemination of digital tools for specific archaeological purposes is often considered of secondary importance. Therefore, it's necessary to develop a curriculum that will allow students and archaeologists to develop geospatial data production and utilization skills. This is the gap that our lab seeks to bridge, the gap between the small archaeotechnological community in Greece and the traditional archaeological training by offering practical and theoretical training on geospatial data production and utilization for various projects. If our experience with the use of geospatial software has taught us anything, this clearly is that geospatial software provides archaeologists with the opportunity to experiment with models and hypotheses without depending on technologies to translate their perspectives into the digital world. With the increasing computing power of home computers and young archaeologists, I emphasize the young archaeologists' growing familiarity with digital technology, geospatial platforms and specialized tools like Unity can be employed more widely. Developing, of course, a GIS curriculum for archaeologists requires careful planning, including identifying learning objectives, selecting appropriate software, designing course materials, and hands-on training. This collaborative approach will involve instructors, students, and technical support, and should tailor the curriculum to the specific needs and goals of archaeological research, while providing a strong foundation of GIS theory and practice. Thank you very much.